Welcome back everyone to this continued series of lectures on combining data frames. And now we're going to discuss how to use the PD merge method. Specifically, we're going to talk about using an inner merge. Now, we already learned how to concatenate data frames together. However, often data frames are not in the exact same order or format, meaning that we can't simply just glue them or concatenate them together. There may be columns present in one data frame, but not present in another. Or there could be rows that are present in one data frame versus not being in another. And in this case, we actually need to merge the data frames together. And if you're familiar with SQL, this is analogous to a join command in SQL, like an inner join, outer join, or left or right join. And the reason we're going to actually go into detail of the different merge types is because actually performing this in Pandas is really simple. It's just one line of code. But understanding what the specific parameters represent is a little more complicated if you don't have SQL experience. So we're going to take a deeper dive into what an inner join looks like or inner merge versus left or outer. Okay, so let's talk about this merge method call. It's going to be PD merge, and it takes in a key argument labeled how. And there are three main ways of merging tables together using the how parameter. And it's saying an inner merge or an outer merge, or then a left or right merge. You can say how is equal to left or how is equal to right, and those are very similar. Okay, the main idea behind the argument is to decide how to deal with information only present in one of the joined tables. So if you have one data frame and you're merging it with another data frame, you have to decide what to do if you only have rows present in one of the data frames. In the combined results, do you want those results to remain except have a null where you're missing information, or do you just want to ignore them altogether? And so this is where the how parameter comes into play. So what we're going to do is we're going to imagine a very simple example. So let's say we have a company and they're holding some sort of conference for maybe people in the movie rental industry. And so people at the company, they first have to register online. So they go to the computer and they register online, and we have a little tracker that registers their ID, meaning what order did they register in, as well as the name of the person. And then later on in the future, when they actually show up to the physical conference, what they're going to do is they're going to log in their name at the physical conference site, and then also say their login ID, essentially what order did they show up in to the physical conference, as well as the name. So then, after the conference, we have these two tables. Notice we have a registrations table. We have the registration ID, what order did people register in, and then the name of those people, Andrew, Bob, Charlie, David. And then we have a logins table, people that actually logged in at the physical site. So something to notice here is not everyone that registered actually went to the conference to log in. Maybe something happened and they couldn't show up. You should also notice that there are some people who logged in at the physical site but forgot to register beforehand. So what we need to do is we need to see that the respective ID columns indicate what order they registered or logged in on the site. So Andrew was the first person to register, and then Xavier was the first person to log in at the physical site. For the sake of simplicity here, we're going to assume that names are unique. That is to say, there's only one person across the entire company named Andrew or named Bob or named Charlie. Obviously, that's not a realistic assumption to make, but since we only have two columns here, we're just going to assume that for simplicity. So again, these names are going to be unique. Only one Andrew, only one Xavier, etc. Also, to help you keep track, what I've done here is the registrations table. The first letters go A, B, C, D, Andrew, Bob, Charlie, David. That's just to help you keep track. Okay, so when we're dealing with pandas and performing a merge method call, we first need to decide on what column to merge together. So we essentially have four different columns here. We have registration ID, a name registrations column, login ID in the logins table, and then a name column in the logins table. And we have to decide what is an appropriate candidate to actually merge these on. So there's basically two rules here. The first one is kind of the most important one. The on column should be a primary identifier, meaning that it's actually going to be a unique identifier for that row. So since we're assuming that names are unique here, if I know someone is named Andrew in one of the tables, I know that is unique for that entire table. There's only going to be one person named Andrew. The other situation that we need to have for an on column is that it should be present in both tables being merged, and it should essentially represent the same thing in both tables. So in this case, name is present in both tables, and it's representing the same thing in both tables. It's just representing the name of the person who either registered or logged in. If we take a deeper look at registration ID column and login ID column, they're not actually representing the same thing. One is representing the order people registered in, and the other one is representing the order people logged in. So keep in mind, the on column, while it can be named differently in both tables, it needs to actually be representing the same thing. Okay, since we're assuming names are unique across the entire company, only one Andrew, only one Bob, etc., then what we're going to do is we're going to merge on the name column. So that means when we actually call PD merge, we'll say on is equal to name. And then next, and this is the also very important part, is we have to decide how to merge tables on the name column. And we're going to first start off with how is equal to inner. So with how equal to inner, the result will be the set of records that match up in both tables. So what we need to do here is we first see what column we're joining on, which is that name column, and then we see where are the set of records that match in both tables. And you'll notice only Andrew and Bob both registered and logged in. Charlie and David registered but forgot to actually show up, and then Xavier and Yolanda actually did show up, but they forgot to register. Which means if I'm looking at how is equal to inner on the name table, I'm only looking at Andrew and Bob since they match in both tables. And merges or joins are often shown as a Venn diagram. So we have one circle representing the registrations table, another one representing the logins table on the right-hand side, and we're going to fill in the middle because we're only looking for people that are in both registrations and logins. And the actual syntax for this in Pandas, which we'll type out in just a little bit, is PD merge, and then your left-hand table, which is registrations, your right-hand table, which is logins, and then you say how you're going to join them. We're doing an inner join here, meaning we're looking for matches in both tables, and then we're saying do this on the name column. So if we look at this step by step, we decide, okay, we're looking on the name column, so I've highlighted it there. Then I'm going to say, okay, I'm doing an inner join. What names are present in both tables? That's Andrew and Bob. And then we're going to essentially merge them together. And when I say merge them together, that means we also grab the rest of the remaining information from both tables. In this case, there's only one extra column of tables, so that's the registration ID and the login ID. And the results would look like this. We have here in the center what they were actually joined on, and then the registration ID and login ID. And keep in mind, depending on what version of Pandas you're using, the actual order of the columns may be different, but the same information should be there. You should now be able to see Andrew's name as well as Bob's name and their corresponding registration ID and their corresponding log ID. So let's go ahead and quickly explore this in Pandas. Okay, here I am in the same notebook that we left off last time, and what I'm going to do is if you actually check out the lecture notebook and you scroll down to the merge section, there's this data table cell which I'm going to copy and paste, which will quickly create the data frames for us. And these are the same data frames that match up with what I just showed in the slides. So if we run this and then check out registrations, I can see I have my registrations table, registration ID 1, 2, 3, 4, and then name, Andrew, Bobo, Claire, David, A, B, C, D. And then we can check out the logins table. And we see Xavier, Andrew, Yolanda, and in this case, Bobo. So we've just changed out the names for B and C, but it's the same idea. You should also note that sometimes you're going to want to join on the actual index, in which case you can always just reset index to get it as a column. But here what we're going to do is show you how to merge these together. And as a quick note, there's actually a lot of documentation on merge. So if you just say help pd.merge and check that out, you'll be able to see that there's kind of full explanations of everything we're talking about here. And if you scroll down, there's examples as well. So let me go ahead and just comment this out. Okay, so we discussed the inner join, and recall the inner join is going to look for matches in both. So we'll say pd.merge, and then we'll say registrations table, logins table. So we pass in the left table and the right table. Then we'll say how is equal to inner, and then we finally say on the name column. And when you run that, you see the following results. You see Andrew and Bobo, and then registration ID and login ID. Okay, so this matches pretty much exactly with what we showed in the slides. Something to keep in mind though is when you're talking about an inner merge or inner join, what's actually happening is you're only taking things that are present in both tables. And for this particular case of how is equal to inner, since you're only looking for things that are present in both tables, the order of your tables that you provide doesn't actually matter. So I could copy this, paste it, and actually provide logins first, and then provide registration second. I run that, and the order doesn't matter. Keep in mind, the order of the rows returned may be slightly different, but the actual information should match up. You'll notice here that the column orders are different, but the actual information is the same. Andrew has a login ID of 2 and a registration ID of 1. That's the exact same thing that's happening here. It's just the columns are in a slightly different order because you switch the order of the tables. So just to make it clear, this is a specific case for an inner method, that the table order doesn't actually matter. When we learn about other methods like a left join or a right join, then the order actually will matter, and it's critical that you understand that. But what we're going to do now is we're going to finish off this lecture saying that's how you do a how inner, and then move on to talking about different join types. So again, it's kind of simple here. You just set up your data frames, you see the registrations and logins, and then you simply call PD merge, the left table, right table, how to join them, inner, and then what column to join them on. And now that we understand that inner returns values that are present in both tables, let's move on to understanding the other parameters that we could provide to the how argument. I'll see you at the next lecture.